Good morning. Okay, everything should be set up, I think, by now. Let's see. All right. Do you see the desktop and do you hear me? Is everything seem okay from your end?
Yep.
Okay, great. Thanks. All right. So first thing we'll do today. Okay, we're gonna start a new topic today. We're gonna switch from talking about arrays to talking about object-oriented programming. That'll be the last main topic we do in the semester. It'll take a little while to do this. Before that, I'm gonna go over. There's another programming assignment for you. So let's start by looking at the programming assignment, spend some time looking at what you have to do, and then we'll start talking about object-oriented programming. So it's on this page, and there's a zip file for it. And the zip file is important for this one. There's quite a bit in the zip file to help you understand how to do this one. Okay, so now what you're going to do is write a program that reads in numbers like this that are considered grades. And this is the grade distribution that tells you what each number represents. So like 87 in this case, 87 would represent a B plus. Okay, so you're going to read in a list of grades and you're going to produce an output like this, like a report. Okay, you're going to produce that output. So it's a program that is essentially a good example of data processing. Okay, so you're going to read in the grades. When your program's reading in grades, it stops when it hits a negative number. Okay, so this will be done with a scanner, and you're reading in integers. So you'll have a loop that reads in integers from standard in using a scanner until it hits a negative number, then it stops reading. Okay, after the program has stopped reading, it starts processing. Your program will need to go through the grades and well, it needs to keep track of how many there are. You have to find the highest grade, the lowest grade, how many A's there were, how many how many A pluses, A's, A minuses, B pluses, B's. So you could do this at either while you're reading the grades, you could be counting them, or you could be storing the grades in an array and you could process them afterwards. And leave it up to you how you want to write the program. But you have to, after you've read the grades, you have to make this report. Then you have to make a little bar chart of how many A's, how many A pluses there were, how many A's, how many A minuses, how many B pluses. Okay. Okay. So your program has to use system.out.print line to print out, that line there, that line there. So you'll print out each of these lines and create this table, and you have to compute how many stars to put here. An asterisk represents 1%. Okay. So five asterisks represents 5%. Like here, I show you a little calculation. Okay, there are three B pluses. There are three B pluses out of 14 grades. 3 out of 14 is 21%. 3 out of 14 is 21%. And as you check, there's 21 asterisks here. So your program has to compute that. It has to do that little calculation. It has to know how many B pluses there are, how many grades there are, do the division. That gives you a number. You round it up to make it a whole number because you have to print out a whole number of stars. You round it up and then you print that many stars for that letter. I mean, another one is the C's. There are four. There are four C's. There were three B pluses. There are four C's. See, that makes the B plus, the C graph longer than the B plus graph. Okay, 4 out of 14 is 0.286, which is rounds to 29%. So you round it to a percentage, a whole number percentage, because you can't draw part of a star. So 29%, there's 29 stars there. You can count them, there's 29 stars. So you have to print out that many stars. So you're going to be working a lot with loops. You can do some calculation, write a loop, like you would write these stars with a loop, because you have to compute what percentage, and that number is how many times you loop to print a star for the C's, and you loop a different number of stars loop a different number of times to print the stars for the B's. In this case, there were no A minuses, so there's no stars there. Okay. Uh, here's here's how you round a number in Java. So I just make sure so that you weren't yeah, in case you weren't sure, that's the line of code that takes a percent and which would be this case that like in this case here, that would be 28.6. So you turn that into a percent by multiplying that decimal number by 100, you get 28.6. Then this line would round it to you to 29. Okay, so I just showed you what that line of code looks like. Okay, all right, so that's what the program does. That's pretty much the whole program. Now, let's look at what's in the zip file. In the zip file is stuff to help you debug it. Let me clean up. I haven't cleaned up my desktop from last night. Um, huh, that's interesting. Those files weren't there. That's yeah. Every once in a while, Windows gets goofed up. It was showing me files on my desktop, but every time I tried to delete them, they got an error message. They really weren't there. They were just show. I'm not sure why the desktop thought they were there. Okay, let's go on. Okay, so here's what's in the file. Okay, first of all, there's a demo version of the homework assignment that you can practice, you can test to see how your program's supposed to work. So in this folder, the demo version's in this jar file. That was an easy way for me to make it available to you. And you run the demo version by double clicking on one of these two files here. These are Windows command files. CMD stands for command files. They're programs written in Windows programming language, which is called the command language. Okay. And I've created these two little programs. These programs run this program. But what it is these programs will ask you for a number, which is how many grades you want to produce. Then this program will run this program, which will produce a bunch of random grade numbers and feed them into the homework demo. The homework demo is this thing. So this file asks you how many grades do you want. Then it'll run this program here, which I give you, this is just for testing purposes. If you want, you can look at the source code of this program and see how it does it, but it generates a random string of grades, okay? And then it feeds the random string of grades into the demo program, and the demo program prints the output. So here's an example. If I double click this, Windows asks me if it's okay to run it. Okay, so I'm going to produce 50 grades. Okay, and there's the output. Your program, when you run your program, if it was given 50 grade, well, in this case, I use this program to generate a random 50 grades, and this is a sample output. In the random 50 grades, there were no A pluses, there was 1A, 1A minus, 7 B pluses. Okay, okay, yeah, you can double check this program. 10 B's out of 50 is 20%. Okay, so there should be 20 B's, and you can see the last star pretty much lines up with the 20. So that's 20% of the grades were a B. Okay, okay, so that's a sample run of the program. Okay, here's the difference between these two runs is one of them produces like here's 50 grades. It's a little bit different. Let me run this program and ask it to produce a lot of grades. Here's 100,000 grades. Okay, there was 100,000 grades. Now run this program and ask it to produce 100,000 grades. This program is computing what's called normally distributed data. The data where there is the center value is more likely, and then as you get away from the center, you get less likely. That's like human heights are distributed. Or that's how that's what people talk about grading on a curve. This is the bell-shaped curve. So this is where you have most of the people in the middle, and as you get farther away from the average, you get fewer and fewer people. This other program is creating what's called uniform data. That means every grade is equally likely. That's like flipping a dice. So that would be like flipping a die with grades on it. So or picking a card from a deck and looking at the number on the card. So this is every grade is equally likely. So you see that the results, there's just as many A pluses as A's, as A minuses, B plus, because every grade is equally likely. So these are two different kinds of what we call probability distributions. So I wrote now I did that just because it was nice to see different kinds of data coming out. So one program creates graves that are curved. The other creates just random grades where every grade is as likely as any other grade. So 100 is just as likely as a 20 or a 30. Oh, actually, the grades are between 50 and 100. I made this program so the grades you'll get are all between 50 and 100, not between 0 and 100. Okay. So in this case, every grade between 50 and 100 is equally likely. And this one, grades at the C plus range are the most likely. That's right in the middle. So that would mean that grades around 75 are way more likely. So grades around 75, there's a lot more of them than on either side or on either side of that. Okay. So that's why there's two different versions of random data. I did that mainly to just kind of make things a little bit interesting. Now, this shows you what kind of output your program can get. Your program doesn't have to generate the data. I'll show you where your program will get its data from. Your program doesn't have to create the data. I mean, that's actually what these two things are here for. These two here will create the data. Okay. So I'll show you in a minute how you can use them to create data. Your program, this just show you what the different kinds of outputs of your program should look like. Okay. Now, I'll go back over here. Here is a file that you started with. Let me start Dr. Java. Okay, there's not much in there. You know, I imported a scanner, and you're going to fill in this file. You're going to write the main method and any other methods that you might think are helpful for you. Okay, I created the scanner so that just that's the object you'll use for reading the data from. Okay, and here's two methods that I wrote the outline of them. That if you think I think they're a good idea. You want a method that computes percent given the number of grades and the total number of grades. So like this would be for if there were 15 A's out of 37 grades, this would be 15 A. This would be the number 15, and this would be the number of grades, and this would just return to you the percentage. Okay, so that might be a useful that having that as a method, I think, is useful. And then this is a method I think that you might want to use that prints one line of the bar chart. So print one line. It's told what letter it's printing. If you think of the output, if you look at one line, you need to know what's this string here that represents the letter at the beginning of the line. So that would be this string. And then the percentage, which that number is how many stars to produce. Okay, so if you know what that is, and you know the number of stars, you can print that line. You print that string, a space, a vertical bar, then that number of stars. Okay, so I think that might be a useful method to have write that method that given those two pieces of data, what's this string here? Notice that if you do it that way, this string here should be 2 characters long. So like for here, it'd be easier if you make that 2 characters, B space, B minus, C plus, C space, and then the letter here will always take up the same amount of space. So then you won't get this thing, it'll be a little bit easier to deal with this. So just, if you do it this way, what's one way to do it. Make this letter always 2 characters long, and then that'll print this column here. Then you have to print out something after it. And then this number here is how many stars to print. And that number there can come from this function here. See, this method computes percents. So the idea, these two should actually work together. This one will compute a percent, and this one will use the percent. Okay, so I kind of give you a suggestion on on what I think. Now, if you have a better way to organize the program, the assignment is that you need to get it to do this graph, okay? And you can come up, if you come up with a better way, a way that makes more sense to you, that's fine. But I thought as a hint, these two methods were maybe a good way to help people get started, that you could use these two methods as a hint. Okay, right. So you have to fill in this program, okay? And when you write a program like this, write it in stages. So for example, the first, the output has to read in the numbers until it gets to a -1. Then it has to output the total number of grades. Write a program that completes, that runs and gives you that output and then quits. At that point, you know that you can read in the data and report the total number of grades. Get that working. Then get your program to find the highest and lowest grade. Get that working. So that as you're reading in the data, you can figure out, either while you're reading it in, you can either do this while you're reading the data in or after you've read the data in, you can figure out what's the highest and lowest grade. So make your program do that much output. Then when that works, then make your program do those outputs and make sure that you get that right answer. Okay. Oh, this okay. Now, if you want to check, for example, you can take this data. Well, we'll see in a minute. Like this is the data for this output. And if you wanted to test your program, it would be a good idea to test it with that data. So, right there, you can copy and paste that data from there. So I can copy that, you know, and if I want, I could see, I can keep that data. There it is as data and I can save that data now. Okay. Now I could save it like as, okay. So now I have this thing stored as data in a file. There's the file I just created. See, there's the text file of that data. Okay. So that's a starting point for being able to test your program. You test it on the data that's in the description. This description shows you what your output should look like with that test data. So that's good data to start with. Okay. Get your program to count that there's 14 numbers here, not including the -1. -1 is not a piece of data. It's the thing that tells you that there is no more data. Okay, so you keep looping on data until you read a negative number, and then you stop the loop. Whatever loop you wrote, for loop or while loop, it will loop until it doesn't know how many numbers there are here. So really probably shouldn't be a for loop. It'd probably be better off being a while loop, but it could still be written as a for loop. You want to loop until you get a negative number. Then you drop out of the loop, and then you could, for example, your loop should keep track of how many times it's reading a number, and you can print that out. Get that part working. Then add code that will find the highest and lowest grade of what it was reading in. Okay? Then, like I say, then put out these lines of code, these lines of output. When you've got all that working with, say, this input data, then start working on getting the bar charts. But don't try to write the whole program and then debug it. This is probably the single most important thing you can learn when it comes to doing bigger programs like this. Don't write the whole thing and then debug it. It just gives you too much to worry about, and it becomes too discouraging. It can be, the more lines of code you've written that you're trying to figure out where mistakes are, the harder it is. If you get this part working where it reads in the data and prints that out, and then you can run that with the input data, then you know it works. And if you can get this part here, you know that part works. That's a smaller amount of code, and you can get it working where there's no mistake in it. Then when you work on this, if there are mistakes, you know where the mistakes are. It's in the new part. When you work on this stuff here, you know the mistake is in the new part, not in the part you wrote before. As you add code to make the program do more, you always know that the new mistakes are in the new code you wrote. That helps a lot. Instead of having to find a mistake possibly anywhere in your program. It should only be in the thing you did most recently. Okay. Okay. So for example, even after you did this part, the next part should be print this part here, the header of this file. Just print the heading. Yeah, because the heading doesn't use any of the data down here. So just make sure you can print that heading out real nicely. Then start printing out the values for the bars. Then start printing out the bars. Okay. Now, the next thing to talk about is how does your program get its input data? Okay. Okay. In here, I've got another test file. See, this test data was the data that was here. I copied this data and saved it in a test file. Okay. Here's another test data. This is a longer one that I gave you. It came with the homework assignment. See, there's a file with test data in it. Okay. And here's what your program should produce output for that test data. So you got two sets of test data. You've got a set of test data that's in this web page with its sample output. Whoops. Okay. And then in the homework assignment is a second set of data in a file and a file showing you what its output should look like. So you've got two samples of data that you can test your program on. Now, when you run your program, you don't want to enter into your program those numbers. You don't want to sit there and type in 81, 67, 78, 90, 69, 77, 75. You don't want to type in all these numbers. Okay. So the idea is that computers should be smarter than that. Computers should know how to a program should know how to read the data from there. Okay. You shouldn't have to enter that data. Okay. So here's a little test program that this program this is like the ones that were in here. These little command files are written in the Windows operating system's programming language. It's called the command language. It gives commands to the operating system to do things. Like these files told the operating system to prompt you for a number. Then after it prompted you for a number, it ran this file to produce data, and that data was fed into this program. So it ran this program, ran this program, and it ran that program. It took the data out of that program and fed it into that program. So when I say I want, say, 6 grades, the 6 grades, these numbers were produced by this program's output, and then that program's output was fed into this program's input. Okay. Now, how did that happen? If you right click on this file, you can edit it and see what's inside of it. Just like you edit Java programs with Dr. Java, you can edit one of these programs and see it's 1, 2, 3, 4, 5 lines of Windows programming code. Now, you don't really need to understand this except that there's one part here that's interesting. See that thing there and that thing there. This says run a Java program. Okay. So this runs the create random number curve grade. So create the random curves. It runs that Java program. And it says save the output from it in that file. When I ran this program here, its data was actually saved in this file here. So there was the 6 numbers, the 6 grades. See, there were the 6 grades. There was an A, there was a C plus, there was a C, there was a D plus. I don't remember what was C. No, I'm sorry, there were 2 C pluses. Yeah, there's another one here. Yeah, yeah, and there's a D plus and there's a D minus. Okay, there's the 6 grades. So when the data was created, it was saved in a file. That's this little arrow thing that says run this program and save its output in that file. Then I run the demo program and I use this arrow pointing in a different direction, which says take this file and make it the input. Now, this is where a program that can read data from a file, this connects the scanner in a program to that file for you. This is kind of a really interesting little piece of magic that computers know how to do. This is part of learning how computers really work in the real world. When you write a program that reads from the scanner, like if I go over here and I take my program over here, okay, I've got a scanner. Let me add a piece of code in here. Okay, I'll say int x equals in dot next int. Okay, I'm going to use the scanner to read something. Okay, so oops, I didn't type that very well. Okay, okay. Now, okay, I said I could declare a variable x, and it should hold the input. It should hold what I read from the scanner. So if I compile this, these won't compile. So let me comment them out for now because they're not finished. Let me just comment them out. Okay. Okay. Now run this program. See, it prompts me. It's waiting for my input, so I can type in a number like 67. Okay. So now X is 67. Okay. But what if I run that program a different way? Okay. Let me actually let me put that in a while loop or a for loop. I'm going to do this 5 times. See, what I just did now is I wrote, I'm going to read X 5 times. Well, did I type something wrong? Yeah, in this case, I need the braces. Okay, because it's a quirky little thing. Because there's a variable declaration there, I need the braces. Okay, so run it. There's one number. There's a second number. There's another number. There's another number. There's another number. So I read 5 numbers. Okay, now notice that the program I just created, it's in the homework 3 folder. See, I just created that class file. I can run that program at the command line if I want to. So here's how you would run that program at the command line. Click if I click in this title bar here and type CMD and hit enter, I get a command prompt. Lets me talk to the operating system. Lets me type these commands that are in these files here. I can type them at the operating system myself by getting up this box here. Remember, you get that by clicking in the bar here and typing CMD for the command prompt that lets you do the command language of Windows. And then I can run my Java program by saying Java homework 3. Okay. Now my program is waiting for my input. The program is waiting. Oops. The program. Now notice I don't get a fancy prompt like I did in Dr. Java. I don't get any kind of actual feedback, but this thing is waiting for me to type in numbers. So I'll type in the number 1, 2, 3, 4, 5. See, the program ended. It was waiting for 5 numbers. Okay. So I can type the numbers in at the command prompt. Okay. Now, here's where things get a little bit interesting. I can take my 5 numbers and put them in a data file. So I'm going to create another data file. So I'm going to create a document call it data2.txt. I'm going to create another data file. Oops. Okay, and on this data file, I'm going to put the numbers 1, 2, 3, 4, 5. Okay, there's 5 numbers in the data file. Okay, now I can go back over here and I can run run the program, but I can say read the data from the data file. This symbol here says, but when you run the program, connect this scanner to that file. So now when I go next int, I'm reading the ints, not from somebody at the, there's no user now. This program is actually reading the data directly from that file. This is a tremendously useful thing. This is how almost all data is processed in the real world. Programs get their data from files, and we use this symbol is called O redirection. Refer to it, and it's explained in the there's an explanation of that in this web page here, so you can read about it. I'm just kind of explaining it here. You can read a little bit about it. Okay. This is called O redirection. It stops me from having to type the numbers. The program just gets its data. See, notice that the program just ran because it read all the data from the file. Like now, let's see if it do something. System.out.println. Let's have it print out 10 plus x. Okay, so it reads in a number and prints out 10 added to that number. So this will make the program actually do something so we could see it running. Okay, so compile this. Okay, now I'll go run it over here. Now what? I'm going to run it with my data file. My data file is 1, 2, 3, 4, 5. I'm going to run the program, Java homework 3, use data2.txt as the input. It read 1, added 10 to it, and printed out 11. Read 2, added 10 to it, printed out 12. And it read, I told it to read 5 numbers, so it read until it read 5 numbers. Okay. What if I deleted 2 numbers from this file? Okay. My program crashed. It was expecting 5 numbers, and there was only 3 in the file. And see, that's why you want that -1, so that your program can sense when it's time to stop reading. See, like my program, I said, give me 5 numbers. There were only 3 numbers in the file. When my program got to there being nothing there, it crashed. Okay. What if I put more than 5 numbers in there? Okay, so now there's more than 5 numbers in there. I'll run my program again. Java homework 3, read in the data that's in the data2 file. Well, my program read 5 numbers. It didn't care that there was more than 5 numbers in that data file. It just didn't even look at the last 2 numbers. It stopped reading when it saw the 5th number, so it did not bother to read the 6th and 7th number. Okay. I can put anything I want in here. Oh, here. Okay. There's 1, 2, 3, 1, 2, 3, 4. Oh, there's 6 numbers. Okay. There's 5 numbers. Okay. Now my program. Now I'm going to run my program again. Oh, notice that I didn't type that. I hit the up arrow key. On your keyboard, if you hit the up arrow and down arrow key, you can recall the commands you've used before. It's called command history. up arrow gives you the last one you typed. Okay. 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 Now, there's the output. Add 10 to 0, add 10 to -4, add 10 to 9, add 10 to 100, add 10 to -5. Okay, there's my 5 outputs. Okay, so yeah, I can put any data I want in here. Now, what's nice is I could put a huge amount of data in here. I could have my program now read thousands of numbers. Okay, oh, so for example, I have here's that larger data file I gave you for the homework assignment. Okay, there's a large data file. Okay, now I can have this program read that data file, but it's only going to read that data file is called test data.txt, but my program only reads the first 5 numbers in it. Okay, so it read the first 5 numbers. Okay, my program doesn't know how much data is in the file. That's why the file has a -1 in it. So instead of reading a fixed, like here, I can have this thing read, say, 25 numbers. Okay, now that's just a guess. I mean, that's just going to read. Okay, if I recompile this, I can run this again. There it read 25. There's a lot more than 25 numbers in that file. Okay, so now I can say, okay, let me read 50 numbers. Okay, recompile it. I'll go run it again here. Now it read 50 numbers. I forget how many numbers are in that file. Oh, well, if we look at the output, the output's supposed to look like this. There are 150 numbers in that file. Okay, so if I make my program read exactly 150 numbers, now it read all 150 numbers in that file. Okay, let's check. The last number in the file is 72, and it put out 82. Now, actually, there's 151 numbers in the file. So we can, if we want to read that last number, we can go here and change our program to read 151 numbers. But notice that I don't have to type the numbers into the program. I don't have to type this program. Now, if I run it here in Dr. Java, I don't have any choice. In Dr. Java, I have to sit here and type 151 numbers. In Dr. Java, the only place the data can come from is the keyboard. But that's a limitation of Dr. Java. It's meant for learning. It's not meant for testing real-world programs. What your homework assignment here is closer to something like a real-world program. It wants to read in a fairly large amount of data. So like here, I don't want to type in 151 numbers. So I'm just going to stop this from running. Now over here, I don't have to type in 151 numbers. I say run homework 3 with standard in connected to that file. Okay, remember the last number was a -1. -1 plus 10 is going to give me 9. So it stopped on that number. Now, if I ask it to read 152 numbers with that data file, I'm going to have a problem because there aren't 152 in that data file. Oops. Okay, so I'm going to ask it to read 152 numbers. Okay, it hit the 152nd number. It wasn't there, and the program crashed. Okay, that's why the negative number was supposed to be a signal that my program should stop. Okay, like over here, here's a fancy way to do that. If x is less than 0, if I have a negative number, we can use this break command we saw the other day in class. Break out of the loop. Okay, so if I see a negative number before I get to reading all the data, I can break out of the loop. So this will read 100. Now, right now, I have a loop that will read 152 and it'll break. Now, your homework assignment shouldn't be written this way because this one's reading a fixed number of input and breaking. Like, what if I want to read 300? What if there's 300 numbers in the file? This thing doesn't read until it finds a negative number. it reads until it finds a negative number or it hits this number here. So this is not a good way to solve the problem, because this one has an upper limit on how much it reads. It'll read at most that many numbers, but it'll quit when it sees a negative number. So let's compile this. Okay, run it again. See, it didn't crash, because when it got to that last number, notice it read the negative one. It read the negative one, changed it to 9, but then quit. Okay, so now you're not actually supposed to process the negative one. So this is from the point of view of the homework assignment, this has got two mistakes in it. It's processing the negative number, and it's also stopping when it gets to 152 input data. You need to write you really should write a while loop that keeps reading data until it hits a negative number, and the negative number is not part of the data. The key here is to see how that I can write programs that can process massive amounts of data this way, because I can have I don't have to sit there and type the data myself. I can use this clever little thing that says, now I have to do this outside of Dr. Java. This is, I get, let me go back and start from the beginning. You have your homework program. You open it in Dr. Java. You compile it in Dr. Java. Okay, so let me change what this thing's doing. Let me add 20 now to X instead of 10. So I compile it in Dr. Java. But I don't want to run it in Dr. Java, because I don't want to sit there and type in a lot of numbers. So I go over here where the folder that holds my program, and I click in this, what they call the title bar, or the navigation bar, and just type now CMD, which is, it's a weird trick. It's actually not even a well-documented trick in Windows, but programmers know this trick and use it a lot. You type in CMD, hit enter, and you get this command prompt. See how the command prompt is at that same folder location. So I'm in this window here is a duplicate of this window here. This window here lets me do things to these files. Oops, they shouldn't have gone away. Linux works the same way. If you get a chance to work with the Linux operating system, I can work with the files here in a GUI way, and I can work with the files here in a command way. So if I want to know what files are in there, I type the dir for the directory listing. So there's the names of all the files that are in that folder. See, data.txt, data2.txt, homework3.class, homework3.html. See, so now one thing I can do over here. Now over here, if you want to run something, you double click on it, but you can't double click on class files. If you double click on them, they do not run. Okay, Windows never is wanted to let you double click. On a Mac, they might. Macs might be a little bit different, but on Windows, you cannot run a Java file by clicking on it. Now let's see, I want that one to go away. Okay, just click. You can double click on exe files, which are real programs in Windows, but not Java class files. But over here, you can run a Java class file by saying Java, then the name of the class file. But notice you don't type the .class. There's a trick. You just type the name of the file without the extension. Okay, so the name of the file is homework3.class. And you don't run the Java file. It needs to be compiled to the class file. You run the Java file, but you don't type the .class. Okay, but I want to run the Java file, and I want to say, but I want the scanner connected to the test data file. Now here I need the extension. I have to type test data.txt. If I do this, Windows will tell me it doesn't know where that file is. See, it can't find that file, test data. Yeah, it doesn't. Here, the extensions really matter. So here I have to say test data.txt. Okay, now my program runs, and it reads its data from there. Okay, and it added 20 to every one of those numbers. If I want to change what my program does, I can go back to Dr. Java, and I can change this to add 30 to every number. Okay, I can make it add 30 to every number. Okay, and I could ask for it to read say 200 numbers, but quit when it finds a negative number. So it's going to read at most now it's going to read at most 200 numbers. And again, that's not the way your homework assignment should be, because you should be. I may test your program reading 10,000 numbers. These programs, like if I go back over here to the sample program, and if I run it, I'll ask for 1,000,000 numbers. Now that program is running and generating 1,000,000 random numbers, storing those 1,000,000 numbers in this file, and then it's going to give me the output. See, it didn't take very long for 1,000,000 numbers. Okay, those 1,000,000 numbers are in here. So it take a little while to open them. There's 1,000,000 numbers. If you ever wondered what 1,000,000 looks like, there's 1,000,000 numbers. You can count them if you want. Okay, that's literally 1,000,000 numbers there. Okay, and that file is, notice it's almost 4 megabytes in size. It takes 4 million bytes of data to hold the 1,000,000 numbers in that file. See, if I right click on here, I can say, how big is that file? That file has 4 million bytes to hold 1,000,000 integers. Okay, because the integers each take up a little bit of space on the hard drive. So every number in that file takes a little bit of space on the hard drive. So altogether, the 1,000,000 numbers take up 4 million bytes. Okay, there's the 4 million numbers. So I could test your program on a huge amount of data. This program created the 1,000,000 random numbers and stored them in this file. Then this file was read into my demo version of the homework assignment. Okay, so there's you want to be able to run your programs with arbitrary numbers of data. So don't write something like this. This one will only read up to 200 numbers, that it'll stop when it gets a negative number. Okay, now I'm reading 200 numbers and adding 30. I compile in Dr. Java. If I make a mistake, I fix it in Dr. Java. Excuse me. And then I go back to my command prompt, which is excuse me. And I can run my program over again. I can run my program Java homework 3, reading the same test data file. Okay, there it added 30 to every input number. Okay, now it would have read a larger file, but this file had 150 numbers in it. The program would have read up to 200 numbers. So it'll quit either when it finds 200 numbers, or it'll quit when this one will quit when it either finds 200 numbers or when it finds a negative number. Your homework assignment has to quit only when it finds a negative number. It just keeps reading until it finds a negative number. Okay. All right. So you notice that that'd be the first step to writing this assignment. Get the loop that will read until it gets a negative number. Yeah, and count how many inputs you're reading. That will give you this first line of output. See, get that part working so that you can give your program can read different amounts of data and tell you how many pieces of data it read. Okay, so get that working. Then work on getting the largest and smallest of those grades. Okay, then work on getting the number of A's, B's, C's, D's, and F's. Okay, then work on printing out the output. Do it in stages. Okay, you can test your program in Dr. Java with small amounts of data, which is not a bad idea. So initially, you would test your program in Dr. Java by compiling it and running it and just see, okay, there's a number. Okay, it's adding 30 to my numbers. Type in a negative number, and it quit. Okay, see, I can initially test my program in Dr. Java, where I type in a few numbers myself. So you initially test it in Dr. Java, and then you can switch to testing it here with a data file. where you can test it with larger amounts of data. Okay. And then you can test it with the data file that's given to you in the homework assignment. That data file there, which should give you exactly that output there. You can't use that data file in Dr. Java. Dr. Java won't let you run a program using a data file. That's actually one of the kind of, yeah, it would be nice if they would improve Dr. Java so you could somehow do that. But it's not really that important. Uh, as students, you should learn how to switch to the command line and do things in the command line. And in fact, professional programmers work with both an IDE and a command prompt open all the time. In the real world, programmers work with both of these windows. The window that is your editor for compiling, editing, and testing your program with small test cases. So like Dr. Java lets me compile my program, lets me edit it, lets me run it with small test cases, and then I have a command prompt open where I can do more complicated things, like running my program with a large test data. Okay, so it's real common to go back and forth. And over here, I can actually compile my program over here if I want to. Okay, for example, let me make a change over here. I'm going to change my program so it adds 300 to the input, and I'll save it, but I'm not going to compile it over here. I can compile it over here. Instead of saying Java, which is to run my programs, Java C is to compile my program. And I type homework3.java. That compiled my program. That's all Dr. Java is doing. Dr. Java just runs that for you. It just essentially Dr. Java, when you click that button, does that command in the background for you. Okay. Now if I run my program, see now it's adding the 300 to every input. So I'm running the different version. Now if I go back over here to Dr. Java and run it, see, I'm running the new version. Dr. Java is running the version that was compiled over here. I edited it in Dr. Java and I compiled it over here. And if I go back and run it in Dr. Java, it'll run the same because they're both using that class file. You know, Dr. Java is working in this folder, and I'm also working in that folder here. You can see the prompt tells me I'm in that folder there. Okay. So I can actually kind of go back and forth. I could compile here or I could compile here. This is the best place to edit. You know, I would do my editing here. The best way to do is edit here, compile here, do simple tests here, do simple tests here, okay? And then use the command line for testing your program with a file, with a large amount of data, okay? Now, one last thing. You can use this demo program to test your program this way. Suppose I run this program here, it's going to give me the curve data, and I want 100,000 data points. So I want 100,000 pieces of data. Okay, there's the output. Now don't close that, just keep that. There is the output with the data. The data I just generated is in that file. So take that file and remove it from here and put it over here. Then run your program here. Run your sample program. Okay, my program doesn't really do anything yet. Okay. Run your program. This thing will run your program, and then but with that data. So that way you can run your program with the same data that the demo program is run. You should get the same output. Okay. So if you run the demo program, it'll store its data that it used in the file test data. If you copy that file to this folder out here and then run this script here, this will run your program with the same data that the demo program has written, and you should get the same output. So you can kind of double check your program that it's getting like that. You could make sure your program gets exactly the same number of stars and asterisks in every row. Okay. All right. And then you can test your program with large amounts of data too. So, because you can go back in here and you can run this program, you could tell this program, when you run this, you can have it create any amount of data. If you want 1,000,000 data points, you can create 1,000,000 data points. So you can test your program with really large amounts of data. Okay. Now there's a lot of here. Uh, there's a lot we've talked about. So this is all going to be in a video. So you might want to review this video later when you're working on the program side. If you forget what steps to do something in, or if you could also come to my office hour or send me an email. If you want any help with the steps of testing your program, feel free to ask, because that's part of what this assignment's about. Part of this assignment is now I want you to run a program that uses a fair amount of data, not just 5 data numbers that you type in a command prompt. See, part of the assignment is that you would use the command prompt with this idea of running your program with data from a file, okay? And there could be large amounts of data in there. Notice that your program, like we've seen, your program does not know it's reading data from a file. That's one of the most important aspects of this. Notice that there's nothing in my program that says read from a file. I'm using a scanner. I'm reading using a scanner. It's the command line that connects the scanner to the file. Windows does that here. Windows runs the Java program and connects the scanner in the Java program to the data file. Now, later on, if you're a computer science major, you'll take a course in operating systems, and you'll learn how this happens. You'll learn how an operating system does this trick. We teach it in the operating systems class because it's part of the Windows operating system. It's a real important trick that operating systems can do at the command line. They can run programs and control where the program gets its output from. Okay, and there's actually a little bit more of a trick. Let me show you another trick here. Notice that when I ran that program, it read data from there, and the output data appeared on my window. If I want to, I can tell it to store the output data in test out.txt. Okay, so there's test data, there's test out. My program's now going to read from that file. Now, here, where my program used system.out, that system.out by this thing is connected to that file. System.in is changed by that thing to that file, and system.out is changed by this thing to that file. Now, when I run this program, I don't see anything happen. The program ran, it read all its data from there and sent all its output to there. So if I want to see the output, I go to the folder. There's test out.txt. There was the data in. There's the data out. Notice I added 364 to get 364. I added 362 to get 362. Added 368 to get 368. There was the data in. There was the data out. Okay. This is how, now, this could have had billions of numbers in it, and this could have billions of numbers in it here. And this is how big databases work. This is how large amounts of data gets processed by programs. You don't have people sitting at keyboards typing in numbers. You have programs running, reading data from files, writing data to files, and then this output file is probably going to be read by some other program that reads it as input and writes its output to another file. And this is how large amounts of data gets processed in the real world. Programs just read data from files and write data to other files, and then another usually notice this data would come from some program that wrote the data into that file. This program reads that data, writes its output to another file. Then some other program will probably read this file and do something else with the data. Okay, we call them data transformations. And they're also referred to as data pipe. What this is building up to is an idea in modern programming, what are called data pipelines. Okay, what is a data pipeline? A data pipeline is just reading data from one file, writing it to another file, then reading data from that file, writing it to another file. And it's just like a pipeline of the data. And each program, when it reads data and writes it, it does some change to the data. Okay, that's how modern data processing works. Okay, in these what are called data pipelines, and you can see there's a huge amount of stuff written about data pipelines. Okay, so this assignment gets you thinking of using your computer in a little bit more sophisticated way. Even though you're prompting, you think of this as prompting the user for input, but really should think of it as reading input data from somewhere. It's reading data from somewhere. It might be a user sitting at the keyboard. It might be, oh, it needs to be recompiled. The program might be reading data from somebody sitting at a keyboard, but it doesn't have to be. The program might be reading data. Something might be connected to standard in by the operating system. The operating system may have connected this. This thing could be connected to an internet site. There's a way to even connect system.in to an internet location. So this could be reading data from a computer on the internet somewhere. So yeah, the idea is your program is just reading from whatever this thing is connected to. And the person running the program gets to tell the operating system what to connect it to. So I could connect this to a different file. Okay, I could connect it to just data.txt is one of my other files. Oops. Data.txt is one of my test files. It's not a very big one. This is the one that has just a few numbers in it. Okay, I can run my program connected to data.txt, and I can put the output in. I'll give it a different name. I'll put it in data out.txt. Okay, so now I'm running this program with that as the input and a new file, data.out, as the output. Okay, it read. Now notice that this file just popped up there. That file didn't exist a second ago. Now it's there. This was the input. This was the output. See, everything in the input got 300 added to it. Okay, so I control at the command line, which is really nice. This is really powerful thing. I control at the command line what system.in and system.out really are. That does not have to be a console window. It can be a file. That does not have to be the keyboard. It could be a file. And later on, you'll learn it could be a network connection or something more. It could be a file, it could be a network connection, or it could be a keyboard or a graphical window like this. Okay. All right. So that's part of what this homework assignment is about, is the getting you to learn a little bit more sophisticated way to use the computer. Okay. Learn to use the computer a little bit at the command line, but mainly the idea that you can write programs that read large amounts of data without having to have somebody sit there and type all the data at the keyboard. Okay. All right. Anybody got any question about the homework assignment, what we said so far? I mean, it's up to you. You'll have to read it and think about it. And so you have questions later on. Yeah. But does anybody have a question right now? Any question about what I've just been saying that you're curious about? Any question at all? Now, remember the steps. You know, when you open this file here, when you open this folder here, to get the command prompt, you just click in here and type CMD. Now you're just typing over what's in there, and it's kind of weird that then when you hit enter, what was in there comes back and you get this command prompt. Okay. So that gives you the command window into that folder. And you can access all the files in this folder now. Okay. And the other thing is in the demo folder, I created little batch files here. They're called command files that will run these programs for you. So you can just double click on those and they do remember, what it's really doing is it's running that program and storing the output in a file. Then it's running the demo program, which is reading from that file. So it asks me how many grades, I'll just say something number, like 8 grades. Okay. See, there's the 8 grades it just generated with a -1 at the end. Okay, so there's what the output looked like. Now I can, if I want to use those same numbers in my program, I can copy that test data into the folder over here, and then I can run my program on the same test data that the demo program was run on. So I could take that file and I could cut it. I could cut it or copy, it doesn't matter. Can cut it from there, go up here, paste it into here. Okay. Now I could run my program with the same test data the demo program ran with, and I do that by double clicking this. This runs your program just like this one. Whoops, I hit the wrong button. Just like this one runs the demo program. This file runs the demo program. In here, this runs your program. Okay, with this test data file as the input. So this script file runs your program with that as the input. And then the output, you can compare it to the demo program's output. Make sure you get the same output. Okay. Anybody have any questions? Any question about this? Okay. Last thing, remember, write your program in steps. Get a piece at a time working. Don't write the whole thing and then try to figure out where your mistakes are, because there'll be too many little mistakes. It'll just be harder to find them. Get the first line of output. Then when that works, and test it several times. Then get the next 2 lines of output. Okay. Then get these lines of output. Then when that's working, then do the bar chart. Okay. Work on it step by step. Get one piece at a time working. Okay. And if you have questions, when you're working on it, please ask. Okay. So I'm going to quit Dr. Java. Okay. And it's an interesting assignment because not only is it a good programming assignment, it's getting you to think about how we really use computers. When Google processes massive amounts of data, believe me, there's nobody double clicking on files and entering data. It's all done automatically by computer programs running other computer programs. So you're starting to see how computer programs like that run other computer programs like your class file. This program is run by that program. This program is written in this Windows command line program. It's a Windows command line program. Oh, remember, you look in what side of those by right-clicking on them and clicking Edit. That lets you see what's inside of them. Okay, same over here. If you right-click on the CMD file, you can open it by clicking on Edit and see what's inside of it. That's code written in Windows command language, which you don't have to really learn it, except the only thing that's interesting is this. That's the only thing I want you to know is that means the output of that program goes into that file. This means that file is the input to that program. Okay, see, the arrow points in the direction the data goes, from file to program. So the data goes from the file to the program. Here it goes from the program to the file. See, think of these as arrows. The data goes from the program into the file. The data goes from the file into the program. This is controlling system.out. This is controlling system.in your program. So that sets this program system.in. This sets this program's system.out. Okay, that's a real important idea. Oh, one last thing. There's actually there's a brief explanation of this in a, if you double click on this PDF. I downloaded this from the internet. It's somebody else's brief explanation of what's going on here. So it's a little with some pictures explaining, see that greater than symbol and the less than symbol. See, running a program called average, Java average, that runs the program called average, but it's reading that data file. So it's computing the average of the numbers in that data file. And he draws it as a picture here, where the data file goes through what's called, this is the system.in, standard in. Okay, so the data file is system.in and the program reads from system.in. Yeah, and there's he explains these ideas using these little pictures. So you can read that explanation. And so it's a little bit of information about what's going on here. Okay, all right. So, okay, now let's start talking about the next topic. We got a few minutes left. Oh, actually, do we have a few minutes left? Not really. Okay. Yeah, we just hit the end of time. Okay, so what we'll do then is we'll start talking about this stuff on Thursday. Okay, so on Thursday we'll start talking about classes. Okay, and you can start working on the homework assignment. If you have questions about the homework assignment, send me emails or ask about them, and we'll start talking about this reading assignment on Thursday. So we'll start talking about writing our own classes. Okay, so we'll quit there. So anybody have any question at all?
I just have a quick question.
Sure.
Um, do we have like an approximation on when the test would be graded?
I'm trying to. No, I'm hoping maybe this weekend. I've got. I've been getting out homework assignments to all the classes I'm teaching, and I just have to crank out one homework assignment after another, and that's kept me from doing the grading. And uh, I'm teaching nearly twice as many classes as I usually teach this semester. And it shows that it's very hard for me to get all the grading done because I'm teaching literally twice as much as what I usually supposed to teach. So it's really caused a delay in having time because I've been the last week or so I've been spending all my time. I've created new homework assignments for all these classes I'm teaching. So now I've got new homework assignments out for all of them, and I'm going to start doing some of the grading. So we'll see. Today's Tuesday. I hope this weekend I can do the grading of the exam. Okay, and because I don't have anything right after I get all these homework assignments out, that's the next thing to do. Okay, it's I'm sorry, but they for some reason I was given a really large number of courses to teach this semester, and it's been a real struggle to get this much work done. So thanks for being patient. People have been pretty patient, and that's really good because I know it's taking a long time for this stuff to come back to you. Okay, so but thanks for being patient. Okay, other questions? Anything else?
Have a great afternoon.
Okay, all right. So we'll do the object-oriented programming on Thursday. Okay, so see you on Thursday. Bye.